All right. A good but rainy and gloomy afternoon to everyone. So, kasi medyo gloomy yung weather maghapon dito sa Kalawan. But hopefully you guys are staying dry and safe and comfortable this rainy afternoon, wherever you are. So, welcome to a new week. This week we'll continue our talk about quantified predicates in Math 101. But basically now we will be doing a parallel of proving validity of quantified arguments, which is very similar to what we did for simple propositions or for unquantified arguments that we have seen, I think, 2 weeks ago. So yun yung pagbabasihan natin ngayon. And you will see that the process is still the same, except that there will just be an added step at the beginning and a possible added step at towards the end of your proof of validity. Okay, and then we will see that a proof of invalidity is a little bit more tedious than what we have seen last time, right? So in particular, here are the learning objectives for the week. First, you should be able to provide a formal proof of validity of quantified arguments. Second is establish the invalidity of quantified arguments. And then let's try if we can start talking about proving mathematical statements using some appropriate method of proof. Kasi kasama siya dun sa study guide for this particular week. Though I'm not sure if we'll be able to tackle that part of the module. So for this week, we'll be covering pages 50 until I think 64, hopefully, of the work text for Math 101. And then depending on what we'll finish on Friday, you'll have a worksheet for due tentatively on October 11th. But if we will not be able to cover most of the things here, perhaps only a part of worksheet 4 will be due, or we will move the deadline to a later date. So whichever is more advantageous to you or more convenient to you guys. So, but watch out. You can try starting working on worksheet number 4 because all of the materials are with you. Okay. But okay, so let's start. So we'll be checking the validity of quantified statements, or actually not just quantified statements, but probably let's call it quantified arguments. Because here we will have again a set of or a sequence of propositions, right? And then these propositions are quantified. And the first few of these propositions are the premises, and the last one would be the conclusion. So katulad pa rin nung klase ng arguments na kinonsider natin 2 weeks ago. So meron kang yung lahat ng mga nauunang propositions which are quantified now are called the premises, and the last one is called the conclusion. But again, they involve quantifiers. But the principle is, again, we will look at the validity of the argument, meaning we will look at the structure of the argument. Will true premises imply a true conclusion, right? Or is it impossible to get to get a case wherein the premises are all true, but we'll get a false conclusion? So ganun pa rin yung idea ng a valid argument. True premises must imply a true conclusion because otherwise we say that the argument is invalid. Pero ang kaibahan niya, as I've mentioned, ay yung mga premises and possibly the conclusion also have quantifiers in them. So for us to be able to use the techniques that we learned 2 weeks back, kailangan nating tanggalin muna yung mga premises, yung mga quantifiers dun sa premises, and then let's use the things we learned from last time, basically the rules of inference, the rules of equivalence, and so on, in order to arrive to the conclusion. Well, there are two possible scenarios. The conclusion might involve a quantifier, sometimes it might not. So depende. Pero to help us manipulate these quantifiers, we will consider 4 more rules that you can add to your rules of inference and rules of equivalence. The first one is called universal instantiation, abbreviated UI, or it can also be called universal specification. And this is one way that we can, or this is the way that we can eliminate a universal quantifier. So if one of your premises involves the statement for all x, p about x, all right? So universally quantified yung predicate p, right? So pwede mo siyang i-instantiate or specify for an arbitrary element of the domain. So if you have this in your premise, via UI, you can put a P of A on your proof or in the first column of your two-column formal proof. So ibig sabihin lang dito si A is an arbitrary element of the domain. Okay? So dahil totoo yung premise, yung statement P about X for all X's in the domain, then it is valid for us to assume that P will be true for an arbitrary or a random or any generic element of the domain. So kaya ang tawag sa kanya specification or instantiation. Nagbibigay tayo ng one particular instant which shows an arbitrary element of the domain. Okay? And in this way, yung mga premises na may for all, pwede na nating tanggalan ng quantifier by specifying not for an arbitrary, not for a generic placeholder X, but a specific but arbitrary element of the domain. Okay? Now, kung sa dulo ng proof, ang gusto nating marating as a conclusion is a universally quantified predicate, then we can use the universal generalization to reintroduce the universal quantifier. So it says that if P of A, but there's a caveat here, provided that A is an arbitrary individual. A is an arbitrary individual. Okay. Kapag si A, dun sa simula ng proof, ay inassume mo to be an arbitrary member of the domain, meaning nanggaling siya sa UI. Okay, di ba? Nagtanggal tayo ng quantifier sa taas ng proof. And then we used A to stand for a generic or an arbitrary element of the domain. Pag si A na-maintain natin yung arbitrariness niya o pagiging random niya o pagiging generic niya or yung pag-denote niya by any element of the domain, then we can universalize the statement P about A to be true for all X element of P of X. But again, make sure that you only do the universal generalization kapag si A ay maintained to be an arbitrary member of your set. Okay? So dapat si A nanggaling sa UI. Pag si A nanggaling sa UI, tapos wala ka ng ibang specific requirements imposed on A, then at the end of the proof, you can reintroduce the universal quantifier via the rule universal generalization. I will say something more about this when we go to the actual proof. So, pero yun lang yung tandaan nyo. Pwede ka lang mag-UG kapag si A ay arbitrary or nanggaling sa isang UI, right? Now, the other two rules are actually parallel to this too, but they deal with existential quantifiers. The third rule is existential instantiation or EI, or existential specification. If one of your premises says that there exists an X in the domain such that statement P about X is true, then you can instantiate or specify an element of the domain that satisfies this. So sabi ng premise, meron nag-exist na X dun sa domain na yung statement P about X ay totoo. So dahil meron, pwede kang mag-say, oh, let me let A be such an X that satisfies P. Now, pag nanggaling ka sa existential instantiation, A is not generic. A is a specific or a particular element of the domain. So out of all the elements of the domain, pinili natin si A to be one of those X's na totoo si P. And I hope you will see that it would be invalid kung mula kay P about A na nanggaling sa EI, bigla kang mag-universal generalization sa ilalim. Kasi si A dito sa existential instantiation ay pinili mo to be one of those X's kung kanino nag-hold yung statement P. Statement P doesn't necessarily hold for all elements of the domain. Meron lang ilang elements ng domain na nagsasatisfy sa kanya. It just so happens, sinabi natin dito sa conclusion ng EI, kunwari, si A ay isa dun sa mga X's na nagsasatisfy kay P. So the variable A here stands for a very specific or a very particular element of the domain. It is not arbitrary, okay? So if in the middle of your proof, okay, or towards the end of the proof, if you will universally generalize your statement coming from a specific or particular element of the domain, that would be invalid. Kasi alam natin si A ay isang specific element ni X. Hindi siya arbitrary kasi yung pagpili natin kay A, dapat si A ay isa dun sa mga elements kung kanino totoo si statement P about X. All right? Now, I've said that you cannot do universal generalization coming from a statement about a particular element of the domain or something that came from existential instantiation. But the most that you can do is do existential generalization. Kapag ka si A ay isang particular or isang specific element ni domain, hindi siya arbitrary, then you can say that there exists an X such that P of X is true. Okay? Si A ay specific. So alam na natin na may kung ito ay nag-appear somewhere in our proof, that means we know that there exists at least one element of the domain. In particular, that's the element A that satisfies P. Okay? Now, yeah, existential generalization. So bawal yung, ngayon, sabihin ko na ngayon, pag nag-UI ka sa taas, tapos ginamit mo si variable A, pwede kang mag-UG using A. So from A. Pero pag nag-existential instantiation ka coming from an element A, bawal ka na mag-UG coming from A. Pag si A nanggaling sa EI, bawal ka mag-universal generalization. Pwede ka lang mag-existential generalization. Pero pag si A nanggaling sa UI at hindi nawala yung pagiging arbitrary ni A along the proof, then you can do universal generalization. Actually, pwede ka rin mag-existential generalization. Kasi kapag katotoo si statement P for all element of the domain, then we know that there exists an element of the domain that statement P about A will be true. So kapag ka nanggaling sa UI, hindi nawala yung pagiging arbitrary nung term A o nung placeholder A, pwede ka mag-UG, pwede ka rin mag-EG. Okay? Now, let's try some examples. But first, clear ba yun? Yung pinagkaiba nung apat na rules? Specifically, yung first set, which is about universal quantifiers, and the last one about the last two about existential quantifiers. Okay, thank you. So siguro if it is a little bit not that clear enough, so makikita natin kung paano siya ginagamit sa proofs, right? So let's look at illustration 34. So it says here, all UP students are intelligent. Okay. Richard is a UP student. Therefore, Richard is intelligent. Yan yung argument, okay? Now, in order for us to write a formal proof for this argument, we need to symbolize this statement, okay, or this argument. The first part is always to declare the variables that you will use for the terms and for the predicates themselves. So that's why the proof will always start, or the proof here started with the declaration of these variables. So we consider statement U about X to be the statement X is actually parang kulang. Dapat ito ay X is a UP student, okay? Because we're talking about UP students as our domain for X. Now, I of X is the statement that X is intelligent. And then probably since there's a specific person under consideration here, siguro i-denote ko by little r si Richard. Okay? And then if I want to symbolize this statement or this argument, then the first sentence goes like this. So analyze natin. All UP students are intelligent. Ibig sabihin kapag ka UP student daw, automatically intelligent. So for all persons X, U of X or being a UP student is sufficient to become intelligent. Of course, we want this to be true, pero it doesn't matter if it is true or false. For the sake of the argument or for checking the validity of the argument, we are assuming this to be true, right? So for all X, U of X implies I of X. And then look at the second statement. Richard is a UP student. So basically, we are applying the statement U to a specific element of the domain. In particular, it is Richard. So the second premise here is U of R, statement U about Richard, right? And U is Richard being a UP student. And then the conclusion, marked by the word therefore, Richard is intelligent. So that means we have I of R, right? Richard is intelligent. Okay. Now, if we want to write the formal proof about this, so you have your two-column proof, you have statements on one side and the reasons on the other. Okay. Now, again, the first step is to to copy the premises. Okay. Premise number 1, premise number 2. Hinopya ko lang talaga sila mula dun sa actual argument. Now, after you have listed down the arguments, we want to get rid of the quantifiers first. So, lucky for us, only one statement has a quantifier, or one of the premises has the quantifier, and it's a universal quantifier. Okay? So, kailangan ko siyang tanggalin, pero ito ay universal. So, pwede ako ngayong pumili ng kahit anong X. Kasi si statement 1, yung material implication dyan, totoo sa lahat ng X. So, pwede akong pumili ng kahit anong X by way of universal instantiation. Because it's a universal statement after all. But if you look at what we want to prove I of R. So gusto kong mapakita na totoo yung statement I sa specific element ni domain. So that means I can choose X to be equal to R for the sake of my goal to show that I of R. So yun yung makikita nyo sa line number 3, wherein I specified premise number 1 or line number 1 to the specific element of the domain R or little r. To stand for Richard. Reason, line number 1, universal instantiation. Okay. Now I could have chosen to use any variable little r. Any other variable other than little r. Pwedeng A, pwedeng B, pwedeng C. Kasi nga, totoo yung statement 1 sa lahat ng x's. Pero kung pupuntahan niyo yung gusto nating i-prove, gusto kong i-prove si I of R. So therefore, i-specify ko na lang. Dahil I of R lang naman yung kailangan kong ipakita, so, gamitin ko na lang na X is equal to R. Because anyway, the conclusion only involves Richard. Okay? And that's valid because universal naman yung statement number 1. It holds for all X, so it must hold for Richard in particular. Okay? So, yun na yun, universal instantiation. And then the goal is to show I of R. But look at lines 2 and 3. We can apply modus ponens here, right? So you have a conditional statement here. We have the antecedent present as one of our premises or one of the lines in our proof. So we can say, oh, I can use lines 3 and 2 and apply modus ponens to them and arrive at the statement I of R. And I of R is the conclusion in the statement, then that's the end of our proof. Okay? Okay, so that's a quick example just to illustrate how we do a simple proof of validity for quantified arguments. Okay, so you see na yung una talagang step, tinanggal ko muna yung mga quantifiers. But in succeeding examples, we will deal with more interesting cases wherein we need to be very particular about the ordering of the instantiation that we will do. Okay. So I hope this is clear. Okay. Now let's go to exercise 35. So exercise 35. Everyone who asks receives. Simon did not receive. Therefore, Simon did not ask. Again, this is a specific, so the conclusion is again specific. It's specific to Simon. But before diving into the proof, declare muna natin yung variables. So proof, we consider the following propositions or the following statements. A of X be the statement that person X asks. R of X be the statement that X receives. And S be the variable, or little s be the variable for Simon. Okay. And then what is our argument, or what's the formal form of the argument? Okay. Can I have some volunteers? Translate sentence number 1. Go ahead, Prince. Bilis ni Prince, ah. I think Prince is typing his answer. So for all x, so he says for all x, switch ako sa chat. Okay, there we go. A of x implies R of x. Okay, that's great. Because if we analyze statement number one, it says that everyone who asks receives. So if you ask, then you automatically receive. So A of x implies R of x. About the second statement, any volunteer? Second sentence? Yes, Paula? Paula Nicole? You can either unmute yourself or type in the chat. Okay, not A of S. Thank you, Paula. Not A of S. Yeah, that's right, because the second sentence says Simon did not parang may problema, Paula. Do you want to change your answer? The second statement is Simon did not receive. So I guess you are referring to the conclusion? Okay, no problem, Paula. Yeah, that's right. Not R of S. And then the conclusion, nadulas na si Paula. So yung conclusion ay not A of S. Simon did not ask. Okay? So this is our argument. And then let's try to write the proof for this. So here we have your statements. Oops. And then we have a reason. And then let me just copy the premises. This would be the first two lines in our proof, or the first two lines in our proof. So reason, premise, premise. Okay, I think we can let go of that. And we want to show not A of S, right? What could be my third step? Volunteers, okay, Rian Pearl, you want to answer? Ano yung third line? Yes, Rian?
A of S implies R of S.
And what's the reason?
1 tapos UI po.
Okay, great. Thank you. Bakit mo napili na i-specify si statement 1 kay S? Kasi totoo siya sa lahat ng element ng domain. So why choose the particular variable little s?
Since yung ano po, yung conclusion po ay ano po, yung may S po. Not A of S
Okay.
po yung.
All right. Thank you. That's perfect because the statement is asking the thing that we want to prove out of this premises is that not A of S, a statement about little s. So specify na lang natin kay little s yung argument, yung premise number 1. And then next step, Crisel, you want to give me the next step, line number 4.
Number 4 po is not A of S na po. 3
Okay.
to modus tollens po.
Okay, great. Thank you. So here we deny the antecedent because we have the denial of the consequent. Dapat hindi totoo si A of S. All right. Okay, great. I think that's the proof. Okay, great. Good job, guys. Everything clear so far? I hope it is. Mukha naman kasi ganadong-ganado kayo mag-recite. So let's move on and look at some more examples. Okay, now this is a little bit trickier. Example 36. Now here we have this argument. Pero wag muna nating tingnan. Basahin muna natin yung sentence pala. So here the informal argument goes like this. No gamblers are happy. Okay, hello again, everyone. Hopefully, I'm back. Sorry, na. Okay, hopefully, I'm back again. Sorry about that. Hold on. Nawala tuloy yung screen sharing ko. Okay, so we were talking about the argument about idealists and gamblers. So, hold on. Kailangan ko magpalit ng Wi-Fi connection. Come on. Okay. Okay, so we're back. Sorry about that again. So, all right. So, pag tinranslate natin siya, so we will use the statement G to denote the statement X is a gambler, H is a statement that X is happy, and I is a statement that X is an idealist. Okay. Now, we're going to go echo. Hold on, guys. Okay. Now, let's see. So look at statement number 1, no gamblers are happy. So ibig sabihin kapag ka gambler ka, hindi ka dapat daw happy. All right? So that's why the translation here is for all x, g of x implies not h of x. Second statement, some idealists are happy. So some signals the use of an existential quantifier. Idealists are happy, so there are some x's such that sabay siyang idealist at saka happy. So I of x and h of x, right? And then the conclusion marked by the word therefore, some idealists are not gamblers. So therefore there exists x's such that I of x and not g of x. So I hope the translation is clear. Now let's go into the proof. Okay, so ito yung statement in our 2-column proof. Now I'll copy the first 2 lines. This would be our premises, or the first 2 lines in the proof. 1, 2, premise, premise. Now, what do you think would be line number 3? And again, in specifying in using specification rules, dapat titingnan nyo or babantayan natin yung conclusion. Pero yung conclusion ngayon nag-work sa specific, ay meron ding quantifier, okay? So we need to be a little bit careful about that. Hindi na mag-work yung specification natin kanina for specific persons of interest, okay? Now, any idea or what do you think would be line number 3? And the clue is we always begin with taking away the quantifiers. So that's our first goal, take away the quantifiers. So what do you think would be the next step? Any volunteer? Oh, yes, Treja. Okay, Trisha says G of A implies, oops, sorry. G of A implies not H of A. And this came from statement 1 via UI, I suppose. Pero, okay. So, supposing tama yung sagot ni Trisha. Thank you, Trisha, for trying. Now, susunod dapat ay tanggalin din natin yung existential. Pero pag ginamit ko yung pagka tinanggal ko yung existential quantifier, I need to be a little bit more careful about that kasi hindi siya nag-hold sa lahat ng x's. Nag-hold lang tong statement number 2 for some x's. So, kung susundin ko si Trisha, kailangan kong gumamit ng ibang variable sa line number 4 kasi si line number 3, ginamit ko yung variable a which is very specific, is very generic. Si a ay arbitrary element ng domain, so mag-hold pa rin yung statement number 1. Pero pag nag-specify na ako ng isang statement or ng isang term that will satisfy the second premise, kailangan ko maging extra careful kasi nag-hold lang siya sa ilang mga x's. And I don't know if premise number 2 holds for the specific a that we used in line number 3. So, nice try, Tricia, though I need to be more technical about this. Pagka nag-i-specify kayo, unahin yung mag-specify. More likely than not, mas okay na mag-specify muna ng existentially quantified predicate rather than a universal predicate. Yeah, I know this can be tricky, but I hope it will be clear later why I want to specify premise number 2 first. Okay? So I'll do that. I'll have I of A and H of A. Okay. And this came from 2 via existential instantiation. All right? Now, inuna ko siya para si A ay specific na. A is specific. Isa siyang specific element ni domain kung kanino nag-hold yung statement number 2. And then I guess after that, Trisha's suggestion would be safer. Or mas safe nang gamitin yung suggestion ni Trisha na G of A implies not H of A. Bakit? Kasi yung statement number 1 ay totoo sa lahat ng x's. Dahil totoo siya sa lahat ng x's, totoo rin siya dapat kay particular A kung saan nag-hold yung statement number 2. Okay? So, though specific siya, okay lang na specific yung term na kino-consider natin dun sa proof kasi tingnan niyo yung conclusion. Yung conclusion ay very specific din, existence lamang. So, kailangan lang nating makahanap ng element na magiging totoo yung I of X and not G of X. All right? So, again, the lesson here is we first instantiate the existential predicates before specifying the universal statements, right? So this is 1 via UI. Okay. So clear ba yon? Nakita nyo ba yung logic kung bakit inuna ko yung EI kesa kay UI? Kasi pag inuna ko yung UI, si A ay magiging random. Okay? Or magiging arbitrary. Pero dahil arbitrary siya, hindi ko sure tuloy kung nag-hold sa kanya yung property 2 kasi yung property 2 nag-hold lang sa ilang mga x's. But if we do it this way, inuna ko yung existential instantiation na nag-specify na ako ng si A ay isang element ni domain kung kanino totoo yung premise number 2. At dahil totoo naman si premise number 1 sa lahat ng x's, so pwede kong gamitin si variable A na nagamit din kay statement 3. Alright? So lesson there, use EI first, then UI, or before UI. Okay? Now, what would be statement number 5? Remember, our goal is show that there exists an x such that I of x and not G of x. So what could be a nice line number 5 to drive us closer to that conclusion? Volunteers? Oh, Neil Christian, go ahead.
Ano po sir, H of A po by simplification po yun sa number 3 po.
All right, thank you, Neil.
Thank you.
Okay,
po.
so H of A specification. Bakit kaya nag-specify si Christian ng H of A? So what could be the next step after Christian's suggestion? Volunteers? So nakikita nyo, balik tayo sa ginawa natin 2 weeks ago, right? Gab, you want to try line number 6? Okay, Gab says not H of A, and the reason is from 5 double negation. Okay, that's great. Line 7. Okay, thank you, Gab. Line 7. Ano kaya yung gustong gawin ni Gab sa ni Neil? Kaya binigay nila yung 5 and 6. Volunteers? Bea? Beatrice, yeah.
Sir, ano po, not G of A po, para po mag 4-6 modus tollens po empty.
Okay, you Bea. That's perfect. So 4 and 6 modus tollens. And okay, nakuha na natin yung kalahati nung nasa conclusion. Okay, not G of A. Now, what's next? Line number 8. Keith, go ahead, line number 8. Yes, Keith. Type ka ba? Okay, there you go. IFA. IFA, and I suppose this is coming from 3 via simplification again. Okay, great. And then last line, I think, hindi pala. Second to the last line, line number 9. Madali lang to. Though Trisha, nakasagot ka na, may points ka na. Let me see other hands. Wala mag-volunteer, so probably I can do it. So, okay, Axel, Troy, you want to try line number 9?
Conjunction pa.
Okay, conjunction, line 7 and 8, tama ba?
8-7.
It's gonna be I of A and not G of A. Thank you, Axel. 7 and 8 conjunction. Ano nga conjunction natin? CJ nga ba? And then, yeah, naka-arrive na tayo sa I of A and not G of A. So that means we have found an element of the domain. In particular, it is the element A, such that I of A and not G of A is true, or that compound proposition is true. So dahil si A ay specific, right? Note ko dito, si A ay specific. Dahil somewhere here we used existential instantiation, then I can generalize. Pero pag nag-generalize ako, existential lang yung generalization ko. So I can say there exists an X such that I of X and not G of X. And this is via 9 using existential generalization. So I am sure that there exists such an element. In particular kasi nakita natin si element A siya. Okay? Pero hindi ako pwedeng mag-UG. Hindi ako pwedeng mag-UG kahit ang conclusion ko halimbawa dito ay for all. Invalid yung pagko-conclude ng for all kasi si A was specifically chosen. Si A ay isang napaka-specific na element ng domain. And luckily for us, yung quantifier ng conclusion ay existence lamang. And that's all that we can do coming from statement number 9. You can just existentially generalize statement number 9. Okay? And this ends the proof. Okay? So, everything clear? Nakuha nyo ba yung moral ng example na to? The example here, the moral here is we do EI first before UI. Okay? And I hope you saw the logic why. Okay. Now, what's next? Tingnan ko kung ano susunod. Let's try 37. I-paste ko dito. Okay. And then I'll have, say, naka-symbolize na yung statement. So sa proof natin, pwede nating simulan ng 1, 2, reason ay premise. Okay. Note that the quantifiers are all for all in the quantified predicates. So what do you think would be a nice third line here? Any volunteers, especially those who haven't spoken yet? Line number 3. Okay, kung walang hindi pa nakapag-recite na gustong samagat, anybody? Anyone? Oh, Perlene, yeah, go ahead.
V of A po implies W of A. Tapos po yung reason ay from statement 1, UI po.
Okay, great. Universal instantiation. Okay, so ngayon, si A ay arbitrarily chosen. Arbitrary. Okay? I-note ko lang sa gilid para alam natin mamaya kung pwede ba tayo mag-UG or EG lamang. Okay? Line number 4. Any volunteer? Sino pa bang di nakakasagot? Biglang nagtawag, no? So, let's see. Aryan, you want to try?
Ano, WA implies not YA. Number 2, UI din po.
Okay, thank you. That's correct. And then, kita nyo medyo relax tayo kapag ka lahat sila ay for all. So sa statement number 3, nag-specify na tayo about about the term A or the subject A, which is fine kasi si 1 nag-hold sa lahat. Pero si statement 2, for all din. So dahil for all din siya, pwede ko siyang gamitin pa rin, nag-hold pa rin siya dun sa dun sa arbitrary element A that we used in the instantiation in line number 3. Kaya valid pa rin yung line number 4. Okay? Thank you, Aryan. So wala nang mga quantifiers. And then luckily after getting rid of the quantifiers, we have A as an arbitrary element. And that's in preparation to the conclusion that we want to reach, which is a universally quantified predicate. Okay? Now, what do you think would be a nice line number 5? Nakasagot ka na, di ba, Perlene and Trisha? So let's try somebody else. Crizel? Di ka pa nakasagot, no? Hi, Crizel.
Hello po. Nakasagot na po ako, pero alam po ba?
Okay, nakasagot ka naman. Jasmine. Sige, Crizel, si Jasmine muna. Di pa yata nakasagot si Jasmine.
VA implies negate YA. Reason po is hypothetical syllogism po.
Okay, lines
3 and 4.
Okay, great. Thank you, Jasmine. So yeah, V of A implies not Y of A, coming from statements 3 and 4, hypothetical syllogism. Palapit na tayo ng palapit sa conclusion. Konti na lang. Yung conclusion natin ay Y of X implying V of X for all X's, correct? So I guess this is the second to the last line. Any takers? Line number 6. Sino pa ba hindi nakasagot? Lauren, gusto mong itry? Lauren Ashley? Talaga namimersa ako ngayon, no? Sorry. No pressure naman. So let's just see if they want to answer. Or sino pa ba? Paula Nicole? Okay, nag-iisip pa siguro sila. Anybody? Okay, yes, Keith Neal. Second time around, tama nga ba? So what do you think is line number 6? Type yata si Keith. Okay, let's just wait a little. Yeah, medyo mahaba-haba yung tinatype niya siguro. Okay, so Keith Neal typed in y of a implies not v of a. Ano yung reason? Okay, contraposition. That's coming from line 5. Contraposition. Anong abbreviation natin ng contraposition? I guess it's called either contraposition or just transposition. I'm not sure how was it named in the rules of equivalence. Yeah. So siguro ano yung TR? Okay, thank you Kit and Crizel. So TR. Pwede ring TP. Yun din naman yung maiisip ko, transposition. Kapag yung abbreviation sa hindi ganun ka-clear, pwede yung i-write out. Or kung nakalimutan yung abbreviation, that's fine. Though either if you write, if you write either TP or TR, that's fine. I can interpret that as transposition. Kahit contraposition, that might also be fine. Okay? And then the last step is to generalize. Kasi yung conclusion natin is quantified. But how far can we go? Well, A is arbitrary. Wala tayong inimpose kay A. Si A ay isang element ng domain. No specific requirement on A. And our conclusion is universally quantified. So we can universally quantify statement number 6. Okay, so 6, universal generalization. And again, we can do UG kasi si AI arbitrary. So end of proof. Okay? So kung makikita nyo, wala talaga ito halos pinagkaiba dun sa ginawa nating proof of validity from 2 weeks ago, except that the first few lines will deal with getting rid of the quantifiers using instantiation rules, UI or EI. And then the last line usually is a generalization statement, okay? But be careful, you can use only UG if you have preserved the arbitrariness of your specific term or subject in your arguments or in your lines in the proof. And if there is a specific requirement you impose on A that made it lose its generality, then existential lang yung pwede nyong i-generalize. Okay? Now, I hope it's fine if I borrow 5 more minutes or so. Okay, you can try 37. Okay, you can try 37 later on your own. Let me end with, ito yung mga kailangan nating points to remember. Or ito yung mga pitfalls in proof of validity using quantified arguments. Okay. Now, if we look at example 38, okay, so puro existential yung arguments, okay, or yung premises as well as the conclusion. And then in the proof, okay, so kinuha niya yung premise 1, premise 2, tapos parehas existential naman sila, so it doesn't matter sino yung unahin mo. In line number 3, they wrote A of A and C of A coming from 1, EI, and that's fine. And here you can note that A is specific. It specifically chosen C A to be one of those X's that satisfy premise number 1. Okay. However, look at line number 4. See, line number 4, it sought to instantiate line number 2. Okay. Pero ang problema rito, ginamit niya rin yung variable A. Okay. Which is already used in line number 3. And meron ditong note, mali daw yon. Bakit sa tingin nyo mali yung pagkakagamit ng EI sa line number 4? Okay, anyone? Bakit kaya may mali doon? Nag-EI lang naman ako. Or nag-EI lang naman si Vortex. Bakit may note na mali? Any idea? Okay, Gab, yes, go ahead. Bakit kaya mali? Si line number 4.
Sir, kasi po yung specific na A, pwede pong hindi siya mag-hold dun sa isa pong statement, yung sa number 2 po.
Okay, great. Thank you, Gab. Yeah, that's right. Kasi dun sa line number 3, pinili natin si element little a to be one of the x's that satisfy condition this property or this predicate, right? So alam natin isa siya dun sa mga yon. Pero hindi tayo sure kung si little a ay isa dun sa mga x's na nakakasatisfy ng statement number 2. All right? Do you get the point? So si A, sure tayo by EI sa line number 3 na satisfy niya si premise 1. Pero hindi natin alam kung si little a ay isa din sa mga elements na nakakasatisfy ng premise number 2 kasi alam lang natin may mga x's. Hindi natin alam kung si little a ay kasama dun sa mga x's na nakakasatisfy ng statement number 2. So probably if you want to do an existential instantiation, for line number 2, you use a different variable. Probably you can say b of little b and c of little b. Ito yung mas tamang EI. Kasi ngayon, si little b is specific. B is specifically chosen so that it is one of the x's that satisfy line number 2. At magkaiba sila. So in this case, posible magkaiba si A and B, posibleng parehas din sila, but we are not imposing that one of them satisfies both of the two premises. Okay? So be careful, kapag ka may dalawang EI, gumamit kayo ng magkaibang variable dun sa pag-instantiate. Alright? So mali na siya from line number 4, so the rest of the proof must be changed accordingly. Okay? Now, some common pitfall, ito. Kapag ka ito ay maling paggamit ng universal generalization. So tingnan nyo dun sa proof niya. There exists an x such that p of x, that's fine. P of a, nag-EI lang siya sa 1. So here a was chosen to be specific. And the conclusion is erroneous kasi nag-universal generalization ka. Ang a mo naman dito ay isang specific element. And showing that something is true for a specific element is not sufficient to show that it is true for everything in the domain. Kaya mali yung pag-universal generalization. Again, si A ay specific na. So the most that we can do is do existential generalization. Okay? So ito ay isang mga common fallacy kapag ka nag-argue yung mga tao sa totoong buhay. Na halimbawa, si politician A ay may nagawa. Okay? So therefore, lahat ng politicians ay may nagawa na. Right? So you cannot generalize from specific examples. Right? And then, yeah, example number 4, statement number 4 is something I need to think about. Ganito rin yung, when I was doing this on the first lecture, on my lecture on the other class, hindi ko rin maintindihan kung ano yung ibig sabihin ni statement number 4. Don't use an EI or a UG on a singular statement. Okay. So I think alam ko na yung ibig niya sabihin. So kung meron kang constant na nag-work yung isang statement, hindi ka pwede gumamit ng EI or UG. Halimbawa, example number 1, someone went to the party. You cannot conclude that a person named April went to the party. Kasi alam mo natin, may nag-exist na tao na pumunta dun sa party, but we are not sure if specifically it was April who went to the party. Okay? And then statement number 2, yung fallacy naman dito. April went to the party, therefore everybody went to the party. Okay? So, hindi ka pwede mag-generalize coming from a specific person to a universal state. Okay? Now, I think I will stop here. Do you have some questions or clarifications? So on Friday, we will start with example 39. And I guess this is an example of showing proof of, showing that a given argument is invalid. So titingnan natin yan next time. And hopefully we can also start talking about methods of proof. But before we end, any questions or clarifications? So I guess, so habang nag-isip kayo ng tanong, browse ko lang yung worksheet. Oops. Okay. So siguro sa worksheet, yung number 1 pala ay proof of invalidity. So you can try doing proof of invalidity if you have time. Read example 39 and everything that follows it. Pero we'll start there on Friday. So most likely, mamumove yung deadline ng worksheet number 4. Kailan? I'm not yet sure. So sabihan ko na lang kayo on Friday. Or I'll let your lab instructors know and relay it to you on Monday. But any questions? Wala naman tanong? Okay, so thank you guys for coming today. I really appreciate it. Again, I apologize for the crappy internet connection. So yeah, let's see each other. Enjoy the rest of the night, and then let's see each other again on Friday. Bye, everyone. Oh, by the way, yung mga nagsagot verbally, paki-comment naman sa chat. Yung mga hindi pa member ng team na walang access sa chat, can you let me know na nagsagot kayo verbally? Or lahat ba kayo ay member? Okay. Bea, okay, hold on. Bea, Perlene, and hold on. Jasmine. So tama ba si Bea, si Perlene, at saka si Jasmine lang? Yung mga hindi pa member ng teams na nagsagot? Oh, Axel, okay. Oh guys, ba't niyo pa kayo member? Request lang kayo ng UP account. So para